Yesterday we talked about vectors, and we all liked the simplicity of the assignment. And today is very similar, but we're adding a third dimension. So today in lesson 8.3, I don't remember what class I was in. Okay, here we go. This is our three-dimensional graph. This is where it's a little tricky. The axis is normal where we would think of it. I'm sorry. No, it's not.
No?
No, it's not. This is X. This is Y. This is Z. Now that looks better. Okay?
Oh,
What's that?
I don't remember that.
Yeah.
Now I put the X, Y, and Z on the positive ends. So these would be the negative ends of our axes.
Why would that happen?
And so our graph would look like this, and then you would mark your points, try to make them equal distant. From the origin. Okay. So if we're asked to locate the point -2, 3, 5, this is how I would do it. Okay? First of all, this is called an ordered what? An ordered triple. It's called an ordered triple. Okay? And it's always of the form X, Y, Z. X, Y, Z. It's always of that form. Okay? And so what happens on this three-dimensional graph is what was the XY plane is laid down. Okay? And so it's, you can't see what I'm trying to demonstrate here on the recording, but this axis and this axis is laying flat. If I can just use rulers. So we normally have our XY plane like this, where this is X and this is Y. We would lay it flat, turn it around a little bit. So here's X, here's Y, and then Z, of course, would come up through there like that. Okay? So that would be our Z axis. And you saw that demonstrated last year in Mrs. Mills' room. That's really cool how she connected those strings across her room. I'm not going to take time to do that today. You've seen it done before. But anyway, if I want to graph this, I'm going to start with -2 on the x-axis. So that's backwards 2. So I go to here. Let me change to go to yellow highlight. So we go to there. Okay? Then along the y-axis, I'm going to go 3. And so some people would go here and go 3. Well, that's accurate. We have to go to the right 3 units. But I need to do it from back here. And so if I connect that, I create a little box. So -2, 3 is this point right here. negative 2, 3. Unfortunately, they didn't say negative 2, 3, 0. They said negative 2, 3, 5. And so from there, I have to go up 5 units. Okay? I have to go up 5 units. And so this is kind of difficult here. Let me see how. 1, 2, 3, 4, 5. So I go up to there. And at that point right there, that's the point I wanted. Okay? That's the point I wanted. And that's how I normally do it. I just, if I'm plotting an ordered triple, I make it looks like a parallelogram because it's trying to be drawn in perspective, you know, trying to make it look like it's a square in a two-dimensional, or a three-dimensional world in a two-dimensional space. So it looks like a parallelogram. But I try to make a square here, or a rectangle, sorry. And then I just stick a stick up since this is positive 5. If it was a negative 5, then I would say it hangs from a string down here. It looks something like that. From that corner, I either go up or down, whatever Z is. All right. Now, if we wanted to fill in the rest of the box, if I go up 1, 2, 3, 4, 5, I come over 3, I get that part of it. Do you agree? If I go back from there, the negative 2 on the x-axis, I get to there. Right? If I do that same thing over here, oops, I went a little too far. So, and if I actually do that. That box, some people like to look at that box to help them draw. Okay? I don't usually do all those other lines. I usually just make my rectangle in the XY plane, and then I either, from that corner right there, I'll go up or down depending on if this number is positive or negative. Okay? What you can't do, and what the book did one time, I'll do this in green because this, yeah. They went up 5 and straight over and put a dot there. Okay? And that's not up 5 units from here, is it? Okay, and so on the test writer, when you're in geometry and we covered something like this, there's a question that asks you to graph that, and it does that. And so I always have to erase it and white it out, and then before I make the copies, or I just totally change the question if I can. So be aware of their mistake. If they would do that, then it'd be easy for someone just learning to do that. Okay, so that is the simplest form of what we're going to look at today. All right. Now, if we add to this, this represents our vector. You know how yesterday we were talking about vectors in the XY plane? And the vector coordinates two, 4 means that I go right 2 and up 4. And there's my vector in standard position, right?
Yeah, it's the quickest distance between the terminal and the origin.
Yep.
The shortest distance, I should say.
Shortest distance between he meant to say the terminal point and the initial point. Yep. Which in this case is the origin. So that's our vector. Well, our vector in three-dimensional space here would be -2, 3, 5. And now, again, as we pointed out yesterday, these symbols are not parentheses. They're vector symbols, which makes them a little more V-shaped. Right, Garrett? A a little more V shape, okay? And you can't really see it because I run it up into that dot, but there's an arrow on this. Okay? So that would be our vector that represents that. Okay? All right, let's move on. I'm going to pause a minute. We're going to copy some things down. So the representation of a vector as an ordered triple, we suppose that point 1 is x1, y1, z1 is the initial point of the vector, and point 2, x2, y2, z2 is the terminal point. And again, as we did yesterday, it's always the terminal minus the initial to find the vector coordinates. And now we use our vector symbols. Okay? Use our vector symbols instead of parentheses.
Is y supposed to be squared in the P1, P2 equation?
Oh, yes, thank you. And its magnitude, the absolute value of vector P1, P2 is equal to the square root of the squares of their differences added together. I should say the sum of the squares of their differences. Okay? So our examples, write the ordered pair, write the ordered triple that represents vector RS, then find the magnitude of vector RS, given that R is the ordered triple 3, 7, negative 1, and S is the ordered triple 10, negative 4, 0. Okay? So we're going to go through this just like we did yesterday, except we add the third dimension. All the rules today are the same as they were yesterday, with the exception of we have this third dimension out here, this Z value. Okay? So we have to throw that in. And so how do I find the coordinates to vector RS? 10 minus 3.
Negative 4 minus 7. And 0 minus negative 1.
Oh, plus 1.
10.
Oh.
Yeah.
Oh.
She's going slow for me because it's notes and we don't want to lose anybody. And so she wrote that perfectly. It's the terminal. Terminal is decided by this. It's the second point in our vector, the way it's written. That's the terminal point. So it's a terminal minus the initial. Okay? And so 10 minus 3 is 7. Negative 4 minus 7 is negative 11. And 0 minus negative 1 is a positive 1. And so this is my vector, represented as an ordered triple, with our vector symbols, not just regular parentheses. Okay? Now we want to find our magnitude. So how do we find the magnitude of RS?
Same thing, but just square the x's and the y's and the z's and take the square root of it.
Okay, I'm liking that. You're saying it's the same as this, except we have to square each of these, right? And then take the square root of it. So, let me clean that back up. So you're saying, can't we just take the square root of 7 squared plus negative 11 squared plus 1 squared? And I want to ask you, did I write that okay?
No.
No, I just wrote it the way I cautioned you yesterday not to write it, correct? We need to put these in parentheses, and I totally agree the first and last one doesn't matter, but that middle one does. If you square that in your calculator without parentheses, it's going to give you a negative 121.
Well, any negative number always in these vector problems will give you a positive.
Right. So 7 squared is 49. Negative 11 squared is 121. And 1 squared is 1. And so that's 171.
Which is approximately 13.1.
I think actually I simplified simplest radical form. And if you double check with me, I think this is 9 times 19, which is 3 square root of 19. If they ask us to round it, then we can. What's that?
You have to plug it back into the formula if you're adding vectors though.
Yeah, if we're adding vectors, we'd have to plug it back in. Yeah, if we're gonna apply the other properties we learned yesterday, then we'd have to, well, no, we don't add their magnitudes. We add their coordinates.
You-
Okay. Something just dawned on me that I didn't have in my notes is a unit vector. So remember, I is a unit vector 1, 0, right? Well, now it's 1, 0, 0. And J was the unit vector 0, 1. Well, now it's 0, 1, 0. And now we add a small k, which is a unit vector 0, 0, 1.
It should have been like this.
And so we can write, if we just take this vector, what was the one we just found on the previous screen?
7, negative 11, 1.
And we want to write it as a sum of unit vectors, then that would be 7i, minus 11j plus 1k, which is just k. Okay? This is how I would represent this as a sum of unit vectors. All right? Okay. Again, I didn't write my assignment down here, so let me look.
No.
13 through 31.
Perfect.
I can live with that.
Or you wouldn't stop.
So today we'll do 13 through 31. So even if you're dyslexic, you'll get this one right. You would flip it around, right?
31
So this number would go first, and it'd be flipped around. This number would go last, and it'd be flipped around. Still be 13 to 31. I'm glad I could make that easy for you.
Or you said,
Moon shadow.